Hi everyone, this should be the first lesson of this week. Hopefully you're on schedule, on pace here. You just got back from the weekend and you're seeing that this is your new lesson, or maybe you're working ahead because this should have been posted on a Friday, assuming I did my job correctly. Anyway, so the topic is solving base E equations. So we're going to be solving exponential equations and logarithm equations. Just everything is going to be base E. You should have watched the video about the number E. We've done a little bit about E in the past. This is going to be a repeat of a lot of the stuff that we've learned, just more of a focus on that number E. So here's what you're going to be doing. You're going to be rewriting exponentials and logarithms. And in case you forgot, an exponential is a structure that has a base, a power, and then the other side of the equal sign. You might call that your answer. A logarithm has a base that would be the same base, b. It has an argument, which is the same as the answer in the exponential form. And then the answer to a logarithm is the power that you would have in the exponential form. But as I said, what we're going to do will be all base E. So when I get to the examples, you'll see that. We will be solving logarithmic equations and exponential equations, which we've already done. Logarithms will be natural log, always, ln. Like before, we'll have to look out for extraneous solutions. When that happens, or that happens because you might be trying to take the log of a negative number. So that's something to be on the lookout for. We'll be solving exponential equations, finding exact answers and approximate answers. That means using a calculator. So let us begin with rewriting these logarithms in exponential form. So we have a base, we have a power equals an answer. So you need to ask yourself, what is the base of this logarithm? ln, which I remember I write in cursive because my L looks like a number 1 and that could be confusing. ln is the same thing as a logarithm whose base is e. So whenever you see ln, you are to know that the base is e. So there's the base. The power in the exponential form is the other side of the equal sign, so v goes up there. And then the answer to a logarithm is the answer to an exponential is the argument of the logarithm, so the u goes right there. So you're going to do number 1 just like that. Mine was all variables. This one has a number in it. Makes no difference. 3 and 4, same thing, just in reverse. So we're supposed to take each logarithm and write it as, take each exponential and write it as a logarithm. So we've got a logarithm, we've got an argument equals an answer. And of course, logarithms always have a base. So here, since the base is e, our logarithm is going to be the natural log, ln. You could technically write log base e, but that's just not done. So please don't. Okay, so the base e here tells me to write down ln. The argument of the logarithm, which goes here, is the answer side of the exponential, 625. And then the answer side of the logarithm is the power on the exponential, 4. So that is that, and that's how you do number 3. All right, real quick, I will check 2 and 4 just to make sure I haven't had a major malfunction and messed it up. So that's right, and that's right. Okay, parts of this assignment may go quickly. Number 6 might be one of those problems as well. We can use the one-to-one property here. The logarithms on each side cancel out. 6 minus 3n equals negative 5n plus 2. Solve this using some basic algebra you learned years ago. So I'm going to add 5n to both sides. 6 plus 2n equals 2. Minus 6. 2n equals negative 4. Divide by 2. N equals negative 2. You might want to go check that. Well, if you plug in a negative 2 here, you're going to have a negative times a negative, which equals a positive. So you can take a logarithm of a positive. If you plug it in here as well, a negative times a negative equals positive. You can take a logarithm of a positive. There's no worry about that being an extraneous solution. That should just be the right answer. So go down and check number 6. And there it is. Now you might be saying, geez, this is exactly what we did last week. You're correct. It is exactly like it, except for the ln. So I want you to be familiar with seeing natural logarithm along with all the other logarithm stuff. So we're just doing this one-day assignment kind of review on this topic. All right, I'm going to sneeze. Hold on. Oh, so sorry about that. I hope you had time to turn down the volume. You didn't hear that in your headphones. Okay, number 8. ln of n squared equals ln of 80 plus 2n. Again, one-to-one property, the ln's cancel out. You have n squared equals 80 plus 2n. Now, it's when you have a quadratic that you generally have to worry about the possibility of extraneous solutions. That doesn't mean it will happen, but it could happen. So how do we solve a quadratic? You need to get every term on the same side. So I take this plus 2n, bring it to the other side, it's going to be minus 2n. Take the positive 80, bring it to the other side, it's going to be minus 80 equals 0. Make that 2n look better. I'm going to solve this by factoring n and n. So two numbers that multiply to 80 and add up to negative 2. Well, you're probably thinking 10 times 8 is 80. Negative 10 plus 8 is negative 2. So that's how it factors. Set each one of these equal to 0. Add 10 over to here, n equals 10. Subtract 8 over to there, n equals negative 8. Could these be extraneous, possibly? Well, if you plug in a positive 10 here and a positive 10 here, there's no way you're going to get negatives. No logarithms of negatives, that's good. If you plug in negative 8 here, negative 8 squared is actually positive 64. Plug in a negative 8 here, negative 16, but 80 plus negative 16 is still going to be a positive number. So no extraneous solutions there. We'll check number 8 just to make sure. Too far. There it is, 10 and negative 8. Again, kind of repetitive of what we already learned. Number 10, again, natural log on both sides cancels out. N squared plus 8n equals negative 10 plus n. To solve a quadratic, we need one side equal to 0, so I'm going to go ahead and minus n and add 10 to both sides. That way this all cancels out. I get over here n squared plus 7n plus 10. To factor this, two numbers that multiply to 10 add up to 7. That's got to be 5 and 2, right? Plus 5 plus 2. Set each one equal to 0. And when you solve them, you should get negative 5, negative 2. Now, something catches my eye. Right here, negative 10 plus n. If I go to try to check these answers, I plug in a negative 5 here. Negative 10 plus negative 5 is negative 15. You cannot take the logarithm of a negative number. That's extraneous. Same thing for plugging in a negative 2. The second answer, negative 10 plus negative 2 is negative 12. You cannot take the logarithm of a negative number. So we did get solutions, but they don't work. This problem has no solution, or you can use that no solution symbol. Let's check number 10, and there it is. Number 12, also a logarithm equation, but we do not have ln on both sides to cancel out. So we're going to have to solve this by some other means. Namely, we're going to isolate the variable by canceling out the 9, cancel out the ln, cancel out the negative 2. So what are the steps? Well, this is negative 9 times ln. So to isolate the variable, we have to do the opposite of times, which means divide. ln of n minus 2 equals, let's see, 18, that's negative 2. To cancel out a logarithm, you drop a base. The base of the natural log is e, so I drop an e here, and I drop an e over there. This cancels out. I get n minus 2 equals e to the negative 2 power. Now, I do not know what e to the negative 2 power is. That's why we have calculators. So here goes. I hit the alphabet button, letter E, hit the numerical keyboard button, raised to the negative 2 power 0.1353. Now to finish this problem off, to isolate n, I'm going to have to add 2 to both sides. Adding a whole number with a decimal is pretty easy. 2.1353. Let me check myself and make sure I didn't mess anything up on number 12. 2.1353. There it is. So just like the other worksheet we did last week where you have to, cancel out a logarithm by dropping a base, it's the same thing except here you're going to drop base e at some point. It wouldn't be the first step here. Obviously, you're going to need to move that 1 over to the other side, but at some point you're going to be dropping a base e. Okay, the next couple of problems say to find an exact solution. So I don't need a calculator. That's why I got rid of it. Number 14 looks very similar in many ways to number 12. A lot of the steps are going to be the same. I'm going to start by dividing by -9 because that's -9 times -9 divide. And it's just a coincidence that it's -9 in both problems. It could be any number there. Anyway, that cancels out. ln of 6x equals 4. To cancel out ln, I need to drop a base e, but I have to do that to both sides. So I get 6x equals e to the 4. Now instead of grabbing the calculator and typing in e to the 4, I'm just going to leave this e to the 4 and then keep isolating x. Now I got to divide both sides by 6. X equals e to the 4 divided by 6. Yes, you could type that in the calculator, round it off and get a decimal answer, but when you leave e as a letter, e, it's not a variable, it's still a number, it's 2.71 something something something, but when you leave it as the symbol e, now that we consider that an exact answer, and there it is. Okay, so those were logarithm equations because they start with logarithms in them. Next, we have exponential equations. We will use logarithms to solve them, but they don't start with logarithms in them. We start with exponentials. So let's solve this. First thing we're going to need to do is subtract 8 on both sides. I get e to the k plus 6.7 equals 72.9. But I think I need some space here because to cancel out e, I needed to take the natural log of this side, which means I have to take the natural log of the other side. K plus 6.7 equals the natural log of 72.9. Once again, I can't do that. We're not looking for a, quote, exact answer. So I need to go function, miscellaneous, hit the ln button, 72.9. Oops, not 7.9, 72.9. 4.2891 if I round off correctly. Subtract 6.7 on both sides. And I'm going to use a calculator for that too. 4.2891 take away 6.7. Oop, not 67. There we go, negative 2.4109. Let's check the answers to number 16. The answer to number 16. There it is. All right, couple more and we're done. Number 18. First step, I'm going to have to divide by 3. E to the negative 3n minus 1 equals 88 thirds. Yes, I could go over here and do 88 divided by 3, but I'm going to use a calculator in a second anyway, so I'll combine some of my steps. Next step will be ln of both sides to cancel out the e, negative 3n minus 1 equals. Now I'll go ahead and use the calculator. Function ln 88 over 3, 3.3787. And the rest is algebra. Add 1 to both sides. Negative 3n equals 4.3787. Divide by negative 3. N equals, and yeah, I need a calculator for that, 4.3787 divided by negative 3. Negative 1.4596 if I round correctly. Hopefully I did. Check number 18. And there it is. Hopefully you're seeing how this is done. You're picking up on it. One more, which I'll work through. Oh, this one's kind of special because of that negative sign there. That could throw some people off. Oops, I didn't mean to do that. Where am I? Here I am. Sorry. Yeah, anyway, let me just continue. So negative e to the 2v minus 9 equals negative 9. Now, because there's this negative sign here, I'm going to divide both sides by negative 1 to cancel that out. Now we need to cancel the base e, so ln both sides. Take the natural log of both sides. 2v minus 9 equals function ln 9 2.1972. And then basic algebra from here. 2v equals 11.1972. Divide by 2. 11 divided by 2 is like 5.5, but yeah, I got to do this in the calculator. 11.1972 divided by 2, 5.5986. Check and see if that's right, and there it is right there. Okay, so that's how this is done. Hopefully that was clear. Go back and rewatch problems if you need to. As always, contact me through comments or email if you have questions, and I will talk to you later.